Good morning. I am Zooey Diggory. I'm with Valley Water, and we are Santa Clara County's wholesale water supplier, also your flood protection district, and we help to steward our watershed lands. And I am deeply honored to be a part of this panel and to work in this really special place. So today, Jake and I are going to take you on an exploration of Coyote Creek's watershed and how the landscape that we know today has been shaped by water resources. And then we'll end with the opportunities that we now have to restore the vital functions of water resources in Coyote Valley. So I'm going to start by introducing a few key terms and processes related to water resources. I want to help set the stage for Jake's focus on the Coyote Valley. And I also want to help you feel more informed and empowered to engage in the Coyote Valley Conservation Area's master planning process. There's a lot of technical terms, but they don't need to be scary or intimidating. So hopefully we'll cover some of those today. So this is an example of the historical conditions in the Coyote Creek watershed, of which Coyote Valley is a relatively small part, actually. It's a big watershed. So the watershed is all of the land, the Santa Cruz Mountains, the Diablo Range, and the valley floor that send rainfall into Coyote Creek, into our groundwater basin, and eventually out to San Francisco Bay and the Pacific Ocean. In our watershed, rainfall hits the ground and flows over the hills and valley floor to create stream channels and floodplains. And these are referred to as runoff. The forests and the grasslands and other vegetation communities help to slow and filter that runoff and prevent erosion, which results in clean water, which is referred to as water quality. So I think I've got a couple arrows here. If someone can, there we go. So there's our hills and our runoff into our creeks. During winter storms, creeks would overflow onto very wide floodplains. And this slowed the water down, which is referred to as flood attenuation. And it deposited the fertile soils that created what became referred to as the Valley of Heart's Delight. That runoff also filtered into the groundwater basin or aquifer, and that's a process referred to as groundwater recharge. And I've got another arrow there to point that out. Thank you. This process also helps to clean and filter our water. And at one point, there was so much groundwater in some areas, such as Coyote Valley, that there were abundant freshwater wetlands, which we'll learn more about with the Laguna Seca. And at the Baylands, that groundwater was helping to keep salt water from intruding into our groundwater basin. Over time, habitats adapted to how this water was moving across the landscape, creating oak woodlands, grasslands, freshwater wetlands, and forests along our creeks. And this natural system was variable and dynamic, but it was also self-sustaining. There were wet years, there were periods of drought, the rivers would flood, some would run dry, and these variations created a diversity of habitats and an abundance of resources for wildlife and humans. And these resources were resilient. They could withstand and recover from droughts and from floods. So next slide, please. As you might imagine, our watershed has been significantly changed. First cleared for agriculture, much of our valley floor has been paved. And with it, we lost some of our watershed's ability to filter and clean the water and for rainfall to make it into our groundwater table. Ditches were dug, creeks were straightened, and levees were built to control how water moved across the landscape. And we lost some of our watershed's ability to slow or attenuate those floodwaters. In addition, we've been pumping water from the aquifer, so much so that in the past, San Jose sank by about 13 feet. These changes, of course, have allowed us to build our communities and industries, but they also caused stream channels to erode, groundwater to drop, and our water quality to decline. So I've got a few arrows here to help point out some of these. That paving of our watershed, thank you, the straightening of our channels, and our groundwater wells and pumping. Okay, so for our next one, thank you. So to address these problems and help replace some of those natural functions and services that we lost in the watershed, we've now built and depend on a variety of infrastructure, which we refer to as built or gray infrastructure. So that includes our dams and reservoirs, which we have 10 of in our county. We've got 393 acres of groundwater recharge ponds which help us get that water back into our groundwater table. And we've got about 100 miles of levees to protect our communities from flooding. So for your reference, our water supply infrastructure now, that includes our dams and reservoirs, our groundwater recharge ponds, pipelines, pumps, and treatment plants, has a replacement value of about $7 billion. Now, don't want to leave you on a low note here. Despite those profound changes, our watersheds continue to provide services that are critical to our way of life. And we now refer to those as ecosystem services, natural capital, and natural infrastructure. And natural infrastructure, such as our natural areas and our farmlands, provide open space and trails for a healthy lifestyle. They still help filter and clean our water. They produce food. They take up and store carbon. They still protect us from storms and floods, and they connect wildlife habitat. Our groundwater table, for example, stores more water than all 10 of our county reservoirs combined. And over a 100-year planning period, these services are valued in the county at $162 to $386 billion. So just as we invest in our built infrastructure to maintain its functions over time, we need to invest in and restore our natural infrastructure, which in addition to providing all of these benefits, also helps increase our resilience to climate change. So how do we do that? This graphic illustrates a statewide strategy for doing just that, which is really putting water where it can do the most good and keeping it away from the areas where it can do harm. So in this example, our built infrastructure is still critical, right? We've got winter rains that are stored in the reservoirs at the top of the watershed. And we continue to have levees that protect our most vulnerable areas, our communities and our industries. But in this example, ditches and some of our levees have been modified so that natural areas and compatible or fallowed farmland are allowed to flood. And this will help recharge the groundwater table in certain settings. It's going to help slow down or attenuate our high flows. And it provides seasonally wet habitats for our wildlife. And I think as this figure really demonstrates, large undeveloped areas like Coyote Valley are important to implementing these kinds of strategies in the future, which are going to become even more important as our climate changes and cycles of drought challenge our water supply system. So with that, I hope you feel comfortable with some more technical terms, and I will hand the reins over to Jake for a closer look at Coyote Valley.
Great, thanks, Zoe. So now that everyone has a big picture understanding of how people and watersheds influence each other and how we depend on our watersheds, I'd like to show how Coyote Valley provides critically important water resources benefits and how by protecting and restoring Coyote Valley, we can help our communities adapt to climate change. So as Zoe mentioned, Coyote Valley falls within the Coyote Creek Watershed, and it covers about 10% of the Coyote Creek Watershed. And you can see in this photo looking west over Coyote Valley, how much land we've been able to protect in this important landscape. Where its valley floor stretches from the city of Morgan Hill, located to the left of the screen, and the city of San Jose, located to the right. And it's defined by the Santa Cruz Mountains at the top of the page and the Diablo Range at the bottom of the page. And Coyote Creek and its tributary Fisher Creek are the two primary streams in the valley. And these creeks meet just at the right of the screen near that label that indicates Tulare Hill, where Coyote Creek then continues to flow north through urban San Jose and eventually into the San Francisco Bay. Stepping back a little bit, Coyote Valley is a really unique area in the watershed. This map shows floodplains along the northern Santa Clara Valley, where the red areas show floodplains that have been urbanized or developed, where flooding can threaten life and property. And the blue areas indicate where floodwaters can fan out over the landscape without causing widespread damage. So you'll see that Coyote Valley, outlined in black, contains over 2,500 acres of open floodplains upstream of the Silicon Valley. And these floodplains are really dynamic. The Open Space Authority has been working in close partnership with Valley Water to understand how water moves through the valley and how we can build back the landscape's health. We've developed this animation that shows how water flows through Coyote Valley and Fisher Creek when it floods. You'll see that these floodplains are not only vast, they also inundate different areas at different times, shrinking and swelling in response to the intensity of rainfall. So these floodplains allows the valley floor to act like a giant sponge that captures and holds water, not only reducing the severity of flooding downstream, but also sending more water into our soils and aquifer. So just give this a second to play out. All right, next slide. Can't get enough of that. And Coyote Valley is also an important area for aquifer recharge. The dotted green outline in this exhibit shows that Coyote Valley is a part of the same aquifer that supplies water to the Silicon Valley. And stippled green areas show undeveloped groundwater recharge areas, where Coyote Valley represents approximately half of the remaining recharge area in Silicon Valley's aquifer. So if these lands were developed and paved over like lands to the north, we'd have to construct more recharge ponds, levees, and dams to offset the loss of the benefits or ecosystem services that we get from Coyote Valley today. But we're actually hoping to take the landscape in the other direction, restoring it to allow for nature and wildlife to return while also making our communities more resilient to climate change. And we're using our understanding of how Coyote Valley functioned in the past to help shape its future. This map was created by the San Francisco Estuary Institute, showing what the valley floor looked like historically. You'll see the different colored areas indicate different habitat types, and the blue lines show where creeks flowed and then stopped as they fanned out over the landscape, kind of in the bottom section of the page. You can see that Coyote Valley was a vast network of very wet valley floor habitats centered around the Laguna Seca wetland, shown in blue in kind of the upper left portion of the page. However, in the early 20th century, a series of ditches, shown by the blue dotted lines, were constructed to drain the valley floor. And dirt berms, also known as levees, shown by the red lines, were built up beside these ditches to prevent water from fanning out over the historic floodplain. And you can see that these ditches sent water directly into Coyote Creek, becoming what we call Fisher Creek today. And more big changes were made in the early 2000s, where a dam and additional drainages were built to lay the groundwork for large-scale development in Coyote Valley. Fortunately, these lands were conserved before this was able to happen, and this infrastructure is no longer necessary today. And we're lucky to have a lot of photographs of this work while it was being done. This photo was taken in 1916 and documents when the lowest lying point of the Laguna Seca wetland was tapped and drained by a steam-powered machine called a clamshell digger. You'll see a white line across the plants in the photo showing how deep the standing water was before it was drained. And once the Laguna Seca was drained, it was burned, clearing most of the wetland and sending immense amounts of carbon into the atmosphere. And all of this work had a huge impact on the landscape's ability to hold water. And this image shows that water that was once 5 feet above ground before reclamation was actually 2 feet below ground after the draining of the wetland. So these changes not only reduced the valley's ability to hold floodwater, it also dried the soils, making it harder for wetlands and riparian woodlands to survive. And so this slide shows where we are today. Looking over North Coyote Valley with San Jose in the background, you can see the network of constructed channels that make up Fisher Creek, the levees and dams shown in orange, making it harder for water to spread out from those channels, and the areas of land that still flood despite over a century of work to try to prevent it from happening. So I want to close with these two pictures, contrasting Coyote Valley in 1916 and today, where so much has changed. And while we look to Coyote's past for clues on what we can bring back, we also need to think about what we need to do to prepare it for our new climate future. And this is where we're starting from with the Coyote Valley Conservation Areas Master Plan, where you get to help us figure out how we should restore Coyote Valley. And we're incredibly excited to begin this work through the master plan process and look forward to working with you all to figure out how to protect Coyote Valley so it can protect us. So with that, I want to thank you for listening and hope you enjoyed our presentation. And also thank Zooey so much for coming in and participating in this presentation as well. We really appreciate it.